interaction is the process of the two or more objects have an effect on each other. And now when we are in particular, we consider for the chemical. So now we can consider the chemical object. And the chemical object here is mean the atoms, ions, or molecules. And the chemical interactions is very important because the chemical interaction is one of the factors which determine the physical and also the chemical properties of particular chemicals. And you can see here there are so many kind of classification. However, one of the most popular classification of chemical interaction is intra and intermoleculars. So what does it mean, the intra and intermoleculars? The intra, it means that inside. The intramolecular, it means that inside the moleculars. And the inter, it means that among or between. So intermolecular is an interaction between the different molecules. For example, with the picture here, you can see that. Can you see the laser pointers or? Hello? Can you see the red laser pointer or?
Yes.
Yes, okay, good. You can see here, so between this one, we consider the hydrochloric acid. And you can see the different interaction here. The first one with the dot here. The dot here is so the interaction between the different molecules. So in this case, we call the dot line here is represent the intermolecular interaction. Intermolecular interaction. Okay, it's intermolecular. It's between different molecules. And also now the bond between the hydrogen and chlorine atoms. This one is intramolecular interactions. Intra, it means that inside, and inter, it means that between. So I think that from pictures it's clear. So what is the difference between the intra and the intermoleculars? Okay. And so now we consider the first type of interaction. This one is intramolecular interactions. Okay, so the intramolecular interaction is the interaction which by the atoms together to produce a molecular or compound. So with this kind of definition, you can see that the intramolecular interaction is similar with the chemical bonds. And because there are three types of chemical bonds, it's ionic bonds, a covalent bond, and metallic bonds. So we can say that so there are three kinds of intramolecular interactions. And in the next slide, you can see that so the characteristic of the interaction of the intramolecular interaction is depend on the properties of the constituent atoms or particles. Especially, it depends on the something called its electronegativities. Okay, first one is we mentioned about the ionic bond. And we actually know from the first part in the molecular structure. So the ionic bond is the electrostatic force between the positive and the negative ions. So it means that they interact with each other by the physical force. Okay, the electrostatic force in Vietnamese is linked and the cú tĩnh điện. Okay, as the electrostatic force between the positive ion and the negative ions. Okay, and normally you can see that so the ionic bond is formed by a combination of metal and non-metals. Because you know that with the metal is less is the metal has low electronegativities. The electronegativity in Vietnamese is độ âm điện. Okay, so the metal has low electronegativities, while the non-metal has higher electronegativities. So the combination between the two elements with very difference in the electronegativities it causes the ionic bond. And you can see that, for example, here we consider the example between the sodium and chlorine. As we have already know from the electronic structure of each atoms of sodium and chlorine atoms, you can see that the sodium atoms is easy to lose one outer electrons, and the chlorine is likely to accept or gain one electrons. In this case, from picture, you can see that the sodium atoms is donates the electrons to the chlorine atoms, and sodium atoms become sodium ions, positive ions, and chlorine atom becomes chloride negative ions. Please remember the name of the ions, the sodium and the sodium cations. However, the chlorine atoms and chloride anions. Okay, so please, I think that you also must be familiar with the name of the chemicals. So here you can see now after the electron transformation from the sodium or transfers from the sodium atoms to the chlorine atoms, you can obtain the positive and the negative charge, and then the positive and the negative charge attract each other by the electrostatic force. In this case, they form the ionic bond with sodium chloride. Okay, this one is the ionic bond. And in converge way with the ionic bond is covalent bond. It's a covalent bond. So in case of covalent bond, if the ionic bond is formed by the combination of the two elements with the big difference in the electronegativities, the covalent bond is formed by the combination of the uh, non-metals of the non-metal with the similar or with the smaller difference in the electronegativities. Okay, and the covalent bond, if the ionic bond is electrostatic force, so the covalent bond is formed by the sharing electrons. And this one we have already known from the first class, the first topic. Okay, and now, for example, you can see here, and also one of the easier way to realize which kind of bond is formed. You can see the constituent items. For example, here with the two nonmetals, so the combination of two nonmetals is normally form covalent bond, and the combination of metal and non-metal is produce an ionic bonds or ionic compounds. And there are two types of covalent bond. One of the example here is we consider the chlorine gas. The chlorine gas is composed of two chlorine atoms here. Okay, two chlorine atoms. And you can see now, so two chlorine atoms share one electron pair. And the electron pair here is evenly shared, or is equally shared between the two chlorine atoms. So each one is the distance from the electron pair to the two nuclei are the same. It means that this one is in the midpoint point of the two nuclei, and this one is called non-polar covalent bond. However, in case of the so in this case, you can see that some the combination of the same type of atoms, the same type of elements, produce a non-polar covalent bond. And however, when we consider another example, for example, for here is the hydrogen chloride. So the combination between hydrogen and chlorine atoms. You can see that in this case, the electrons are likely move towards the more electronegative element. For example, here when with the hydrogen and chlorine atoms, we know that there's one electron pair between a sharing electron pair. However, because the chlorine atoms has more electro negativity, so the chlorine atoms will attract the sharing electron pair, and it means that so now you can see here the sharing electron pair is moved toward the chlorine atoms, and in this case they cause a polarized of the molecules. Because this one is now is not as equally shared between the two atoms, and when the electron pair here moves towards the chlorine atom, so it means that at the end of chlorine atom here it should be has a partial negative charge, and at the end of the hydrogen atoms there is a positive, there is a partial and positive charge, and this case they form the polars. This one is the electronic. This one is electronic polars between the negative and the positive. This one we call is a polar covalent bond. And this kind of polar covalent bond is produce a molecular dipole, molecular dipoles. Okay. Maybe I will translate a little bit in Vietnamese. Như các em nhìn thấy đây là trong trường của HCl đúng không ạ? Thì cái cặp electron dùng chung này đúng không ạ? Nó lệch về phía clo, tại vì lúc này clo là nó more electronegative, nó âm điện hơn là hydrogen. Và khi nó lệch như vậy thì cái đầu clo này nó sẽ có một phần điện tích âm, còn cái đầu này nó thiếu electron, nó phần điện tích dương, và lúc này ta có two polar đúng không? Ta gọi là có hai cực đúng không? Là hai cực. Vậy lúc này ta gọi là dipole, di này là hai, mà pole là cực, giống như là trái đất của ta có hai cái cực đó. Thế nên người ta gọi là molecular dipole. So you can easily realize that. So when we we make the combination between the two different type of elements, it will cause a bond dipole, the bond dipole. And so which element with is more electronegative, is will be has a partial negative charge, and for the more positive, more electropositive element, it has a positive charge. Okay, this one is for the covalent bond, and please keep this in your mind for the polar and non-polar bond, because we will come back to this point when we consider the intramolecular interactions. Okay. So the non-polar and polar. Non-polar is không phân cực and polar is phân cực. Okay, non-polar covalent bond liên kết cộng hóa trị không phân cực, and polar covalent bond liên kết cộng hóa trị phân cực. Okay, so you can see, when you can see this to these two pictures, you can realize what does it mean non-polar and polar. Okay, as the non-polar here, it means that this one, the electron are equally shared between the two atoms, two nucleus. However, in case for the polar one, it's not a non-equally sharing electrons here. And so the next one and the third one, and also the last one of the chemical bonds, or the intramolecular interaction. Here is metallic bonds. Okay, so please consider, because you know that there are two basic type of elements. The first one is non-metal, and the second one is non-metals. So when a metal combined with a non-metal, it produces the ionic bond. And when two metals, and when two non-metals combine, the combination is produce a covalent bond. And only the last option is when the metal combined with the metal is produced the special bond with the name is metallic bond. And there are so many theories to describe the metallic bond. And here in these lectures, I may consider one of the most simple theories, which is electron C models. Electron C models. Because when you learn more in another course, for example, when you consider something like the material chemistry, something like this, there's another kind of method to describe a structure in the metals. However, here we consider only a very simple one. So you can see from the picture here, in kind of the metallic lattice, in the metal lattice, it's not the neutral atoms. It's not the neutral atoms. Here you can observe this one is metallic cations, and also the electrons. And so according to the electron C models, so we assume that each of metal atoms, first one is donate the electrons, and then they become the positive ion here. And what's happened with the donating electrons? And here, with the donating electrons, they form which one is electron C, or we can say that the C of the delocalized electrons. It means that this electrons is not only fixed at the positions of the metal ions. However, these electrons can move freely in the lattice, in the metal lattice. So from this kind of structures, you can see that the metallic bond has both characteristic of the ionic bond and also the covalent bond. First of all, you can see here they should have electrostatic flux between the positive metal ions and the negative electrons. So this one is a characteristic of the ionic bonds. However, with the when you can see here the metal ions or the metal atoms use not only, so the metal ions here they share a sea of electrons, and so when the metal ions or the metal cation share the electrons, so this one is a characteristic of the covalent bond. So if I say that, so the metallic bond it can be considered as a company as the mixtures between the covalent bond and also the ionic bond. So here's from these pictures. Sorry, questions. Do you understand the structure of the metallic bond which I described?
No.
Yes.
Another from another persons, please. Don't be shy when say I don't understand. You should be honest with yourself first. Đừng có xấu hổ khi nói mình không hiểu nhé. Tại vì xấu hổ như vậy là chết đấy đúng không ạ? Nếu như mà hiểu tất cả rồi thì ok, tôi không phải diễn đạt lại nữa. Còn nếu không hiểu thì tôi còn diễn đạt lại đúng không ạ? Còn nếu rõ ràng nếu ta hiểu hết rồi không có câu hỏi gì thì ta move further. Okay. Okay, so this one is a metallic bond. It can observe in the pure metal or in the metalloids. The metal alloys. The metal alloys. For example, you have the inox. Okay, the inox is the iron alloys, or normally you call it steel. The inox is inoxidable, or this one is very stable with the oxidation in the normal atmosphere. So this one we call is inox. Okay, this one is not from English, this one is from French. Okay, so and you can see here, because this kind of structure, with this kind of structures, you can see that with the delocalized electrons, this one can explain why the metal can conduct the electricities. So you know that when you apply the electric field, or when you apply the electric field on the metal, you can see that the electron here can move in a particular direction. And this one is produce electricity. And the similar way with the thermal conductivity of the metal. For example, when you heat up the metal at this point, so because here the electrons can gain the energy from the thermal, from the heat, and they can move from here to the whole lattice, mean that they can bring the energy from this point to another point. It's why you can see that the metal is thermal conductors. Okay, so it can, and also for the duct, the malleable or the ductile properties of the metal can explain when we consider this model of the metallic bonds. However, the first one is the intramolecular. It's not the main object, the main point of this topic. However, because we shift to the next one about the intermolecular interaction, we make the summarize here with the table. You can see that there are three main type or three strong intramolecular interaction. The first one is ionic bond, the second one the covalent bond, and the last one is metallic bond. And this one is a model for each of ionic bond. So the ionic bond is alternative arrangement of the cations and also of the anions. Okay, so and the basic attraction here is between the electrostatic flux between the cations and the anions, or between the positive ions and the negative ions. And the energy of the ionic bond is about 400 to 4,000 kilojoules per mole. This one is very high energy. And this one can explain why the ionic bond is normally a solid at the room temperature at the normal conditions. Okay, and also this one is has a high melting point and boiling point. And ionic bond, some of ionic bond can dissolve in the waters, and when dissolved in the water or in the molten form, the ionic bond can conduct electricity. This one is some of the physical properties of the ionic bond, which depend on the structures of the bonds. And now you move to the covalent bond. You can see the covalent bond is formed by the sharing electrons here, by the sharing electrons. And the basic attraction here is between the negative charge of the electron pair and the positive charge of the nucleus. And the energy of the covalent bond is lower than compared to the ionic bond. It's only from 100 to 1000 kilojoules per mole. And also because with the weaker bond energy, so normally the covalent bond has low melting point, boiling point, and also normally they exist in the liquid and gas forms. And for the metallic bond is formed as is formed between the metal ions, and the nature of the metallic bond is the attraction force between the metal cations and the delocalized electrons, and means that the electron here can flow freely or move freely in the metal lattice. Okay, and the energy of the metallic bond is somehow compared with the covalent bond. However, here the problem here, you can see that the covalent bond is composed only a limited number or small number of the atoms. However, in case of metallic bond and also in ionic bond here, it's formed from a great number of particles. A great number of particles. For example, one hydrogen molecule contains only two hydrogen atoms. However, when you talk about sodium chloride, or for example with iron, is metallic iron, we cannot say about the only one or two particles. It's one about very huge number of particles. It's why yes, normally the ionic bond and the metallic bond can exist at the a solid and has a high melting point and boiling point. Okay, this one is some summary for the intramolecular interaction or for the chemical bondings. And now I think we can move to the last point. The next point is about intermolecular interaction. And the intermolecular interaction, as I have mentioned, the intermolecular interaction here is the force, the interact, how the particle effect on each other. And this one is between the particle. It's not inside the group of particles. This one is between the different particles. And normally the intermolecular interaction is much weaker than the intramolecular interaction. And in spite of the weaker interaction, the intermolecular interaction also shows a very important role in the physical properties of the chemicals. And here is a classification of the intermolecular interactions. So you can see that there are 6 types of intermolecular interactions. 6 types of intermolecular interactions. The first one is hydrogen bond. This one is one of very special interactions. And then is ion dipole, ion-induced dipole interactions. Okay, and the last 3 interaction is related to the dipole interactions. Okay, dipole, induced dipole, and oscillating dipole and induced dipole. And the last 3 types of intermolecular interaction is considered as van der Waals interactions. This one is very famous, is well known in the chemistry. So when you mention about the van der Waals interaction, it means that it's 3 different kind of interactions. Okay, so this one. I think that first we should, sorry. Okay, so now I think that we should take a break a little bit before we continue the intermolecular interaction. Maybe it's 5 or 10 minutes.